Hello everyone, welcome to our channel CodeChef. Today we are going to solve a problem, sales of watches from CodeChef platform. It is of Cakewalk difficulty level and it requires no prerequisites. So let's understand the problem statement first. There are two brothers, Ram and Gopal, and they are very fond of collecting watches. Now a sales of watches is going on in their city for a week and both of them want to buy the watches, but they can buy them only within certain limits which is imposed on them by their mother, so that the possibility of getting watches is reduced. So now every watch has some rating RI and some price PI associated with it. So the instructions which are imposed on them are, on an even weekday they cannot buy a watch which has odd price and odd rating, and on an odd weekday they cannot buy a watch which has even price and even rating. The third instruction is the price of the current watch should be less than the price of the last bought watch, and the fourth condition is the rating of the current watch should be greater than the rating of the last bought watch. And the fifth condition says that if all the conditions are satisfied in a particular day, then it is compulsory to buy the watch for that day, since they don't know the prices and ratings of the watches of coming days in the sale. That is, if a watch for a certain day is satisfying all of the above four conditions, then we have to simply buy it. There is no choice of skipping that watch. Now what is our task is, we have to simply calculate the maximum number of watches that can be bought in the sale. And also it is given that weekdays we have to consider that they are going to start with 1. That is, the first day will be counted as first weekday and second, third and so on. So with the fifth condition, it is clear that we have to only check for a watch whether it is eligible for getting bought or not. That is, if a watch is satisfying all of the conditions, then we have to simply buy it. So the task simply reduces to check if a watch can be bought or not, and that can be checked simply by applying the first four conditions. The one thing we should notice here is, for the first watch we need not to check the third and fourth condition, because for the first watch we can simply say that it is the first watch which we are going to buy, so we need not to check the price and rating of the last bought watch because we have not bought any watch yet. So for simplifying this condition in the implementation, what we can assume that there is a sale which is going on day 02, in which we have bought some watch that has some minimum value associated with it which is not possible in the input, and some very large price which is not possible in input again. So we can assume a watch having this, so that the first watch doesn't count as special. That is, we need not to specify that if it is the first watch which is going to count or not. We can simply assume a 0 watch. So let's see the sample input. So for the first test case, we can assume rating of the 0 watch as -1 and price of the 0 watch as some large value greater than 1E9, say 1E9 plus 1. Now for the first watch, we can see that it is the first weekday and it is having even price and even rating, so we cannot buy the watch. So our condition gets filled here. Now for the second weekday, which is even, we have to make sure that the price and rating of the watch is not odd. Since they both are odd, so we cannot again buy this watch. For the third day, we have to make sure that our rating and price of the watch is odd, but the price of the watch is even, so we cannot buy it. Similarly, for fourth day, we can see that the price of the watch is odd and also the rating is odd, so it is not eligible for getting bought. For the fifth day, we can see that again the price of the watch is even, but the weekday is odd, so we cannot buy it again. For the sixth day, we can see that the price of the watch and rating of the watch are both odd, so we cannot buy it again. For the seventh day, we can see that the price of the watch is even and the rating is odd, but since the price is even, so we cannot buy it because both of the price and rating should be of odd parity for this odd weekday. So here our answer is simply 0, which is same as the sample output for the first test case. Now let's consider the second test case. Now let's see the second test case. So we can again assume the 0 watch having rating as -1 and price as some large value 1E9 plus some number. Now for the first day, we are seeing the price is 1963 and rating is 3. we can see that both of the values are not even, so we can buy this watch on the odd weekday. Now the rating of the previous watch is also less than the rating of the current watch, and the price of the current watch is less than the price of the previous watch, so we can buy it. And as per the fifth condition, if we can buy some watch, then we have to simply buy it. So our answer will get 1 in this case. Now for the second watch, we can again see that the price is 1958 and rating is 4. So rating is greater than the previously bought watch, which was the first watch, and the price is smaller than the previously bought watch, which is the first watch. So again we will buy it, and the answer will become 2. And similarly for all of the watches, we can see that the conditions will get satisfied and we can simply buy them, and the answer will become 7 for this test case. So now let's have a look on the C++ implementation of code. In the 7th line, we are taking the input of t, number of test cases. Then for each test cases, what we are doing, we are simply initializing an array which is going to contain the price and rating of the 7 watches. We are here taking the 1 base index, like p of I is going to contain the price of ith watch on the ith day. So here our array is going to store the price and rating from the index 1 to 7, and then what we are doing, we are simply iterating on every day and checking if the current day is odd, then we are making sure that the price is not even, similarly the rating is not even, and the price of last bought watch is greater than the price of current watch, and the rating of current watch is greater than the rating of last bought watch. And if the conditions are getting satisfied, then we are simply incrementing our answer and we are updating the price and rating of the previous watch as P of I and R of I. Similarly for the even day, we are considering that the price and rating of the watch is not odd and the price of the current watch is less than the price of the previous watch, and similarly the rating of the current watch is greater than the price of the previous watch. And if all the conditions are satisfied, then we are again incrementing an answer and we are updating our PW and RW variable, which are going to contain the latest bought watch specification. So at last we are simply printing our answer. So this is the code. It is running successfully on the sample test cases. We can say here that it is outputting the answer 072, and on submitting it is giving us the correct answer. Now let's have a look on the Python implementation of the problem. So in the first line, we are taking again the input of t test cases. Then for each test cases, I am creating a list of prices and rate and taking the input of that. Now here I am using the zero based indexing, that is the value of the first index is giving us the price and rating of the watch on the first weekday. So while considering the watches, I am just checking I plus 1 value, that is if I is 0, then we have to consider it as 1. Here PW and RW are storing the specification of the last bought watch. Here the 0 watch, price having some large value and rating some minimum possible value. And then for each watch we are going to check the condition, that is for the odd weekday they are following the conditions correctly or not, and similarly for the even day, and if they are following the condition, then we are going to simply increment the answer and going to update the details of the last bought watch for both of the weekday, even and odd, and at last we are simply going to print the answer. Here we can see that it is passing the sample test cases, and on submitting it will pass the entire test cases. So let's see on submitting. So yeah guys, here we are seeing that it is giving us the correct answer on submitting. Now let's have look on some of the error codes we can have. So here the major errors we can have when we are initializing the price of the 0th watch as some random value, which can be possible in input. Like we can have some test case in which the first bought watch has the price greater than 136. But since it is the first bought watch, like the watch which is first eligible for getting bought, and we have to buy it simply. But as per our code, its price is greater than the last bought watch, so it will not get, so we will not add it in our answer while it has to be added. So here we are going to get the wrong answer. So we have to make sure that we are initializing with the correct price and rating value, and also in checking the condition we have to make sure that we are applying the right condition, that is the price should be greater than the price of the last bought watch should be greater than the price of the current watch, and the opposite for rating, that is the rating of the current watch should be higher than the rating of the last bought watch. So we have to make sure that we are applying these operators correctly. We are not messing it up like we are comparing two wrong values. So we have to make sure of it. So that's it for the video guys. Thanks for watching.